Hello everyone, welcome to the next video of the course. I hope all of you are eager to learn VHDL now that you have learned some basics of the digital circuits. As I've mentioned before, this is not going to be an exhaustive course which teach you VHDL. Nevertheless, we'll be having enough number of examples to get familiarized with VHDL. And here we are, let's start. Yeah, so to start and programming language and that to a hardware description language, the easiest way would be to start it with an example, and this is the example what we are going to do today. So I have got a two input AND gate over here with the inputs I0 and I1 and the output is O0. Okay, and the corresponding timing diagram or the waveform is shown over here. I0 is 0 initially, then it becomes 1, then it becomes 0 and again 1. Okay, I1 is 0 initially. After two changes of I0, I1 becomes 1 and it becomes 0. Okay, corresponding to this you can see that when I0 I1 are zeros, O0 is 0 and I0 I1 1 0, that combination O0 is again 0. And for this combination I0 being 0 and I1 being 1, O0 is again 0, and we know that AND gate gives you a logic high output when both of the inputs are 1s, right? So this is what we are going to implement today. Okay, let's get started. For that, let us invoke the Quartus software. I've already installed the software. Hope all of you have installed it. Okay, if you invoke Quartus for the first time, you will have a splash screen like this. It is asking for you to start a new project. That is what we are going to do today. So just click on create new project wizard. Okay, then it will ask you for a directory in which you want to create a project. I have already created a directory on my desktop. I'm just pointing to that directory. So it is named as EE232. Okay, so I just selected that one and I need to give a name for this project. Again, I'm going to give EE232 for the time being. Okay, so this one is getting filled automatically. Let it be that way only. Okay, after this you can press next. So here, if you are doing it for the first time, you don't have to do anything. But if you are doing it, if you are creating a project after writing so many VHDL files, you can add all the files here. But now we are not going to do anything here. We simply press next. Okay, here in this window we have to choose the target device. Okay, I have mentioned to you that in the introduction class we will be dealing with some CPLDs or FPGAs, right? We are going to make use of Cyclone 2 family device from the Altera Corporation. Okay, so you have to click on Cyclone 2 and the device name is, you have to click on this name filter over here and you can type EP2C5T144C8. So this is the device name what we are going to use. Okay, so if you enter that here, in the list you can see only one device is there. You click on that and then press next. Okay, in this window, what you have to do only one thing. In the simulation row, you have to select Model Sim Altera from the drop down list, and here you have to make sure that it is VHDL. Okay, we are going to make use of VHDL. Then press next, and once again verify whether everything what you have entered is proper. Then press finish. Okay, with that, the tool has created this environment for you. You can just get familiarized with this window and make sure that on this project navigator window under hierarchy tab, you have to make sure that you are seeing Cyclone 2 EP2C5T144C8. That is our target device. Okay, now we can get started with VHDL programming. Everything else is ready. So for that, let us click on this new button, or you can press Ctrl N for that matter, and then click on this VHDL file over here, then press OK. Okay, a new blank file has been created. Now we can start programming here, right? So I hope all of you are familiar with any of the programming languages. So there are like separate sections for writing something different, right? Here in VHDL, we have to start with the library declaration. Okay, so the command, the syntax is library space IEEE. So we are going to make use of the IEEE library. Okay, then we have to tell the tool that inside the IEEE library, we will be making use of so and so packages only. Okay, for that, here what I'm going to use is IEEE.std underscore logic underscore 1164. So this is the package which I'm going to use, and then I have to write .all. So that completes that statement. Now I have selected the library and the packages inside that library. Now I can start with the this coding of the AND gate. Okay, so how do we start with that? So in VHDL, you have to give the information to the tool in two separate sections. In the first section, which is called the entity, you will just define the external stuff, or you will be just giving the port information. For example, this is having two input ports. This AND gate is having two input ports and one output port. Okay, that information is what you are going to give in as part of the entity, right? So we have to start writing entity. Okay, so there is an auto finish. It will show you suggestions. You simply need to press enter. Okay, so the syntax is entity. So here I'm going to have a two input AND gate. So I'll just name the entity as and underscore 2. Okay, entity name, then is. So this is the structure is very similar to English language. You can write entity name is. Okay, that is a structure. And inside this entity, you have to start with the port information. Okay, this is where you give the port information. So start with port. Then I have I0, there is one input port I0, and I have another input port I1. There are two input ports, right? Then these are the labels of the input ports. Now I have to tell the tool that these are inputs. So the syntax is in. Okay, so I have given the direction of the port. The next thing is that I have to tell the tool that this particular input is of type, say, data type X. Okay, and the very first data type we are going to get familiarized with is with the logic standard logic data type, which is the superset of your logic 0 and logic 1. Okay, so the data type is std logic. Then I have to end this line by pressing semicolon, right? Now I have to give the output name. Output is nothing but O0, again colon, then direction, it is out. It is also of the type standard logic. Okay, now that the port declaration is over, I can close the bracket and I have to end this bracket with a semicolon, right? Then I need to end the entity too, right? And entity, then again semicolon to mark the end of that particular statement. Okay, here I would like to emphasize one thing. So I have written library in small case and IEEE in uppercase, so on and so forth. But VHDL is not a case sensitive language. Okay, so even if you write capital letter IEEE or small letter IEEE, the compiler will interpret it in the same way. Okay, even if you have mixed cases, it doesn't make any difference. So you have to keep that in mind. Okay, now I have given the peripheral information to the tool. Then what else I need to give? I need to tell the tool that this is the architecture inside this entity. Okay, you have to give the peripheral information, followed by you have to give the internal information too. In VHDL, these two are separated into different blocks. One is the entity declaration and the other one is architecture. Okay, the syntax is something like this: architecture, and you have to give an architecture name. Here I'm going to give the name as functionality. Okay, functionality of. architecture name of what? The architecture of the entity. Okay, so I have to give the entity name over here. Okay, and to is, right? It's again similar to English language. Then I can write begin. Okay, I'm going to begin the architecture over here. Then here I just simply need to define the relationship between the inputs and outputs. Okay, so that can be written something like this: or not. Or not is assigned. Okay, so the assignment operator in VHDL is something like this. This is one of the types of assignment operators, less than equal to. Okay, that also gives you the signal flow information, right? Now that output is an AND of I0 and I1. So I can write I0 and I1, right? That completes the statement. Then I need to press semicolon 2, right? So our work is done here. Now we can end the architecture too, right? So end functionality, right? So that completes the uh, architectural description, right? So you can also see that it is following some kind of color coding, right? So all these blue are reserved keywords, okay, and these red ones are also keywords, but the tool differentiates it in some fashion. And whatever you write in black, that is where you have control over. Okay, these are the names and labels what you are giving to the entity and the signals and the architecture name, etc. Okay. Having said that, there are some restrictions for naming. The name has to always start with a letter. Okay, I can't start with a digit over here. Then letters are permitted, and numbers are also permitted, and underscore is also permitted. None of the other characters are permitted in the name, right? Okay, now that we have completed the code for AND gate, let us save it, right? So you just need to press Ctrl S. Remember that our entity name is AND underscore 2, right? So yeah, so it is on desktop. By default, it is taking the project name what we have given, but we have to give the entity name as a file name. Otherwise, it will create some problem. So I need to give AND2 here. Okay, then I can press save. Now we have written the code. Now we are ready for running the compilation and simulation, right? Let us do that. You have to go to the processing menu, then click on start compilation, or you can also click Ctrl L. Yeah. Okay, it has thrown an error. Let's see what it is. Top level design entity EE232 is undefined. Okay, that's a very familiar error, but you may see it plenty of time. What it says is that we have mentioned that our project name is EE232, and we have also mentioned that the top level entity name is also EE232. But the file what we have here has the name and underscore 2, and the entity name is also and underscore 2. Okay, that is the reason why it is throwing this error. So what we have to do is that we need to make this particular entity as a top level entity and simulate. Okay, so what you have to do is that you have to right click on this one, then click on set as top level entity. Yeah, then compile again. You can also press the button over here. This play button is for start compilation. It will take some time depending upon your speed of your processor, etc. And okay, the compilation is proper. So some warnings will be there by default. So most of them you can ignore. We will worry about this much later. For the time being, you can ignore. And you can take a detailed look at this summary report too. You can see how much is the utilization, how many pins are used and stuff like that. Okay. Now that the VHDL code is compiled, we can see how the logic circuit look like. For that, what you have to do is go to Tools, then go to Netlist Viewers, then go to RTL Viewer. Yeah, so here it is. If you press Control, then you use the scroll button, then you can see the architecture. And the architecture is very simple because we have written a code for a simple AND gate. What else can we expect over here, right? Okay, but this is how you make sure that, visually make sure that everything is in order. Okay, then you can press close. Yeah, now it is time for us to simulate the design. Okay, for that what you can do is go to Tools, Run Simulation Tool, and click on RTL Simulation. Then it will invoke the Model Sim tool. Again, it will take some time. Yeah, now the tool has been invoked. Where you have to go is to the library sub window over here. There will be a work object, and click on the plus symbol next to it. Okay, then you can see the entity which we have created. Now you can double click on that. Right, once you do that, it will show all the objects inside the entity here. So basically objects are nothing but your signals, input ports, output ports, and if you have any other wires inside the design, all those will be listed over here. Okay, and you can select which all signals you want to visualize as the waveform. So I am going to select all, pressing Ctrl A. Then if you right click, then you can click on add wave, or simply you can click Ctrl W to add all the waves. Okay, now I have got all the waves over here. Yeah, all the signals are here, and here on the right hand side you can see the values of all these, right? And for the time being, all these are undefined. U stands for undefined, right? And if you run the simulation by clicking here, run, or pressing F9, you can see that all the signals are red in color, which means that either the signals are undefined or you are having some errors. Okay, now let us assign some values to these inputs and observe the output. Okay, just you can do that by right clicking on each of these labels. I'm clicking on I0 first, then go to force, then here you can see the value as U. I'm going to make it 0. Okay, again I'm going to repeat the same thing for I1. Again I am going to press 0, right? So you just need to make assignments to the inputs, not to the output. Then you can press this run button. Yeah, now both inputs are zeros, and as expected the output is also 0. Now let us validate the other 3 possibilities too. I'm going to assign I0 to be 1, and I1 remains at 0 itself. Okay, I0 is 1 and I1 is 0, still the output is 0. Now let me make I1 to be 1 and I0 remains 1 itself. Then I press run. Okay, now you can see that the output has changed its value to 1. And let us complete all the input combinations by making I0 to 0. Okay, then press run. Again, the output went back to 0 again, right? So that completes our simulation because we have verified all the possible input combinations, right? Yeah. Now let us close this window. Okay, we have done this simulation part manually now. There is another way of doing the same thing, which is known as the test bench method. Okay, for that what you have to do is that you have to create a test bench and instantiate the AND module inside that test bench and then simulate. Okay, it may sound a bit complicated, but let me give you a demonstration of what it means. Okay, for that again you have to create a new file, VHDL file, press OK. Then the first line is as before, it has to be library. It need not be the first line, you can have comments too. Then I have to use the IEEE library. Then comes use IEEE dot std logic underscore this one. Then I need to, now comes the entity section, right? Entity declaration. For entity declaration, here I'm going to have a test bench. So I need to give another name. So I'll start with entity. I'm going to give and2 underscore tb as the test bench name. Okay, this, right? And I don't have to have any ports here because this is a test bench. Okay, I can readily end the entity. Yeah. Now I need to give the architectural description, right? So the statement is something like architecture, then architecture name. I'm going to have test bench as the architecture name. The name can be anything, that's up to you. Of and to underscore TB is, okay, so that is the complete line. So here, before we type in begin statement, we have to tell the tool that we are going to make use of our AND gate inside the test bench, right? For that, one of the easiest way is to copy this entity declaration, okay, then paste it after the architecture, right? Okay, I'll just make some modifications of alignments. Okay, but here you can't have two entities. Instead of entity, you have to rename it as component, right? Okay, so that part is done. So this is something like you have the function prototype defined in your main program, something like that, right? Now that part is done. Now we need to give some signals. So these I0, I1, O0 are the ports of the AND gates. But inside the test bench, we need to have some wires which needs to be connected to the inputs and outputs of your AND gate, right? And those wires are known as signals in VHDL. So we have to define it in this fashion. So the signals can be, let me name them as, let's say A, B and Y. Okay, so A and B are for input and Y is for the output of the AND gate. Now I have to tell the data type of these signals. So the data type is nothing but STD logic. Right. Now that we have the component and the signals ready, we can begin our architecture. Right. Yeah. So now the function prototype is there, but we have to call the function, right? So that is known as instantiation in VHDL. How to do that? We have to give a name. Here I'm going to give a name, DUT. DUT stands for design under test space colon. Then the design name. So I'm going to test instantiate the AND gate 2, right? So AND underscore 2, right? So that is syntax. Then I have to give the port map. Port map is nothing but the signal A is connected to signal I0, B is connected to signal I1, Y is connected to O0, right? For that I have to write port map, then give A, B and Y. So this is known as positional mapping. Okay, now that the we have instantiated the AND gate inside our test bench. Yeah. The next step is to assign different values to the inputs, right? For that, what we have to do, we have to write a process. Okay, process is something like a collection of consecutive statements. Okay, then inside the process, again you have to write begin, right? So this begin statement, you can observe that there is a begin over here and begin over here also. So most of these VHDL constructs will be having this particular syntax. Okay. Inside the begin statement, what we are going to do is that we are going to assign different values for A and B, right? So I'm going to assign logic 0 to A first. Okay, so you have to keep in mind that the assignment operator is again less than equal to, and then for bit data type I have to give it in this fashion: single tick 0 single tick, or 0 within single quotes, right? Then I can end this particular statement, but again I can write another statement here. So this semicolon is kind of a separator, right? So for the sake of simplicity, I'll write it like this. I'm going to assign 0 to B2. Okay, then I'll have to wait for some time. Let me wait for say 1 nanosecond. That is good enough, right? So that completes the first statement. Now I can copy and paste it multiple times and give different values, right? Let me copy it for 5 times. So I will make A as 1 over here, then B as 1 over here, and A and B both as 1 here. And the last statement has to end with a simple wait keyword. Okay. Yeah, now these statements are enough. You can make sure that all the possible input combinations are covered. Then you can end the process over here. Again, you have to press a semicolon to end the process. That is good enough. We can end the architecture 2 and test bench, right? Now it is time for us to save. What should be the file name? Yeah, the file name has to be and underscore 2 underscore tb because it has to be the entity name itself. Okay, now that we have made this test bench, we can't compile the test bench as we compile the design. The procedure is a bit different. For that, what you have to do is that you can go to the project navigator and double click on the files. You can click on any of the items. You can click on hierarchy too. And here in this settings window, you have to choose EDA tools settings. Go to EDA tools settings, go to simulation. Okay. Most of the things you leave as it is, but here in native link settings, you have to click on compile test bench because we are going to use a test bench over here. You click on this radio button. After that, you have to click on the test benches. Then here you have to click on new. Right. Now we have created test bench file, right? That has to be given here. So we can click on the browse button, click on the and underscore 2 underscore tb.vhd, right? And you have to give the top test bench name. Our test bench name is nothing but and 2 underscore tb, and that is our top level module in the test bench, right? Now we just need to click add here. Now you can see that this name has appeared over here. Okay, and after that you can press OK, then again OK, then again OK. Now that the setup is ready, now we can compile the design by pressing Ctrl L. Wait for some time. If you see any red statements over here, it is nothing but errors. Okay. The greens are just statements, and there are some warnings. These blue ones are like critical warnings, and the yellow ones are non-critical warnings, so on and so forth. We will come to that much later. Okay, now that we have compiled the design as well as the test bench, we can run the simulation, right? So we can either go to tools, run simulation, run RTL simulation, or you can simply click here, this window, which says RTL simulation. Now that will invoke the model sim window. Yeah, so many things are happening. So here you can see that since we have given the test bench, all these manual things what we have done before has been already taken care of by the tool. So all the waveforms are already here. And you can see that there are waves like this, and if you scroll, use the like the seek button, you can see that the waves are changing. The one good thing, one easy thing what you can do is that you can just simply press here and click here and press F. That will give you a zoom fit. Okay, and here you can again verify that it has taken all the values, the input 0 0 1 0 0 1 1 1, all the combinations, and the output is 0 for the first 3 combinations and output is 1 for the last combination. Okay, so that is how you can make use of test bench. So this is very simplified usage of the test bench. You can do it in a much more efficient and complex ways. We can do that much later. Right. Now that part is also over, what else is remaining? Yeah, the comment thing, right? So what is the code without any comments and documentation, right? Let me just enter a comment here. So the comment starts with 2 hyphens. Okay, so this is a VHDL program to implement. Okay, so typically I'll write the who is coding this, right? Yep, that is how you add comments in VHDL. Okay, so in case if you are not having this quarters installed on your systems, still I recommend that you install it on your system, because this is what we are going to use for our lab too. So it's better that you get familiarized with this. But in case you don't have the provision to do that, you can make use of an online tool which is called the address is edaplayground.com. Okay, you have to go to that one, and it may appear something like this. Okay, this is the default appearance. Okay, let me just refresh that page. Okay, now you have to go to languages and libraries. From the drop down list you have to choose VHDL. Then by default there are some one test bench is there and one design is also there, but you can just like delete the content for the time being, because otherwise it will create some problems. And you can click on the plus button over here and click on upload files, or you can just copy paste the file, or you can even code the design here. I'm going to have the and2 design there. Okay, and 2.phd is uploaded to here. Then again on the test bench side you click on plus button, give the test bench file and to underscore tb. So I think I am selecting a different file there. Yeah, so this is our test bench. Yeah, so I have the test bench and the design ready. Now what we have to do is that in the top level entity you have to give the test bench name. So the test bench name is and underscore 2 underscore tb. I'll just copy paste it here. Right, we have mentioned that this is the test bench what we are going to simulate. Then we can click on the tools and simulators. From the drop down list you can choose Aldec Riviera Pro 2020.04. By default the compile options will be there, and you can give runtime as 5 nanoseconds, because we have given, let's say, 4 nanoseconds of like we are given 4 nanosecond duration, so let us run it for 5 nanoseconds. It doesn't make much difference. Then you can check this box, this checkbox, open EP wave after run. So that will give you the waveform window 2. You click on that. Then you can just click on this run button, or you can press Ctrl Enter 2. Okay, it says that I have not logged in. Let me log in. Right, so everything is saved. So by the way, you might have to create an account here. Right, it is simulating. Yeah, now the waveform window has popped up, and you can just verify that again it is having all the signals in order. Here A, B, Y are the signals in the test bench, and I0, I1 or not are the signals in the design. And both are kind of replicas of each other, right? It is just that it is having different names, but nevertheless what we have to worry about is the functionality is proper, right? That is how you can make use of EDA Playground for the VHDL simulations. Okay, I have listed I have pasted all the screenshots over here for your reference, right? This I'll share with you. Then as practice problems, what now you can do is that you can write the codes for all the basic Boolean gates and try to simulate using the method which I have detailed here. With that, let me wind up here. Thank you.